Let me come back to the application here. I was just telling you about the street data. The street data, whatever I have, has got a specific width. Now here the data what I am going to use going to be area in nature. Initially I told you roads can be represented as a line as well as a area. In this context I want to use the street data. Now wall to wall projection from one wall to another wall, that could be part of the street, that also can be represented, or it could be only the area which is used for say movement. Now that is what is the tar or the concrete portion. So that could be one, that also could be present in that. So out of the total width of 30 feet, about 20 feet is meant for movement or vehicles or personal, and the sides on either side you have say about anything, something like your platform or any other thing. For example, if I am going to work with the street data, I want to widen this 30 feet road has to be widened to much further. Let me make it 40 feet or 50 feet. So if this is the application, you can sit in your laboratory, need not visit the field, use a buffer technology, we will just see all the details and then identify the areas which are going to be affected by your enlargement. We will see that later. Now coming back to this example, that street data. As a planner, I was telling you, this is my data, this is my raster data. I just started again to show you, make it easier, comfortable for you. This is my raster data which is indicating the street data and also the water supply and the wall, all these details are there in this data. I am going to convert into GIS. You can see that how the data is converted here. These are all your land parcels and each of the land parcels are connected with the water supply here, you can see here, or it could be even sewerage, does not matter. If it is going to be water supply, you can also have indicate the valves wherein which we regulate the flow of water. You can see here from a simple drawing to a map which is so useful, which can be analyzed, manipulated, visualized. Now this is how the data appears, and the entire area, as you can see here, is converted or shown in the map. You can see here the I was just showing the previous slide a small area. Now the entire area shown here, you can see how the roads are shown here, how the water supply lines are there, and you can also number them. All these details can be brought into a GIS. You can see how useful from a simple drawing wherein which you had a raster data which cannot be interpreted, which cannot be edited. I have brought it in such a way, we have converted the data in such a way that I can use it independently. In fact, the most important thing you have to bear in mind is here, this data what I have shown you in the last slide is indicative of say each and everything is different. This is one layer, these walls are one layer, this water supply is one layer, the land parcel is one layer. You see, one single drawing has given me 4 different layers of information. So this is what is GIS is all about, a very powerful tool which can separate these various objects which are present on the surface into different themes and use them accordingly. Now coming back to the next point, how to get the data from say a point data, that is what we observe in the field in the form of a point, isn't it? So this point data has to be converted into a map part of it. The point data what I get, I told you I can use a GPS. It could be a handheld GPS or it could be a high end DGPS or any other method of getting XY. Get the XY data and then convert that in such a way the map or the GIS environment will be able to understand that. So use that. So I can show you here now for a particular application. In a particular district, I have a XY coordinate here, X the I told you in the longitude and the latitude, and the data is given here, and this is the basic data I get from the field. When I use the simple technique of converting a point data, I am able to convert the data which is in the form of XY in a map as a point data. Now this has reference to a specific coordinate system. So that is how we do it. So we are able to convert the XY data into a map here. You can see here various applications will be there now. Now what are the various capabilities of a GIS software? How far you can use that? So we have just seen how the point data is converted, how the street data, line data and the area data like land parcels. This is only the tip of the iceberg. You can make wonders with GIS. Let me show you how well you can use your GIS in various applications. Just to start with the capabilities of a GIS data. Management, how do you manage the data? First thing is that you have to obtain the data pertaining to that particular object, attribute information and then attach that to your spatial object. So, the field data to spatial objects, again this is also in the field only, but still we are able to do that. We should also have the capability, that software should be also have a capability to link the data to external databases. In fact, majority of the applications or majority of your say projects, especially government projects, they have huge database. Most of the data is converted into soft copy, but incidentally they are only in spreadsheet, maybe in Excel or something like say or Access database, or it could be even in any other method. But still, what am I going to do with the data? How am I going to use the data? So, when I have spatial data, I want to use the data which is already typed. I told you how spatial data is ready using GIS. I have collected the if I have collected the data from field, I can link it, but the data, if it is already available in some form, a soft copy form, then what is the point in recollecting the data? So, I will have to incorporate that particular data which is available in say Excel or MDB or whatever is that data has to be brought into a GIS system or environment rather. We can use that as a linking to external databases, that is an existing database. Then we should be also capable of making changes to the existing database, because existing database will not be accurate all the time, because it may be errors. So, we should be able to make changes to that, and above all update the database features. So, anything you want to add, any kind of, because what is available with the government or any other organization or any other society may not be directly useful for your study. Hence, we should be able to update the data. If I have 10 fields, I may be in a position, I should be in a position to incorporate many more fields. That should be done directly, isn't it? I should not find it difficult. So, normally what we tend to do is that we use something like called as a common pointer or a common field, a field which is created in the GIS environment, which will be similar in your external database. Simply link the data. You ask the system to link, it will automatically link the data, but it does not know what it is linking. It depends only on your important connecting field, namely the ID. A unique ID is given for both the non-spatial data and spatial data. By clicking of the mouse, you can connect the data from an external database to a spatial database. So, that is what is the big advantage you have in GIS now. So, we will be able to, I told you, update the database features, and then also important aspect you have to remember is that I should be capable of import and export the data from my GIS to software to another software, or from other software to my software, vice versa, either GIS database or the DBMS database. So, both of them should be possible. So, I should be able to import or export it, just not by linking the data, I should be able to export the data. So, this is what is an important thing. Then very important is that when I have a large area for study, for example, when I am doing Chennai city, 1170 square kilometers of area, what is that I am going to do? How is that I am going to work with that? Definitely, I cannot cover entire city in one single scene, isn't it? Satellite will not be able to see the entire 1170 square kilometers of area. When I am talking about say very large resolution satellites, it covers hardly 40 or 50 or 60 square kilometers of area, not more than that. So, in that context, when I want to do say 1670 square kilometers, I need more number of scenes. So, satellite will be scanning the data or imaging the data in scenes. So, I will have to use different types of data, and if you are not lucky, you may not be able to get data of similar dates or within stipulated time. You may get the data which will be of different dates. So, such a facility should be there in a GIS environment to convert the data and then put them together. That means, large areas, different database you have to have and then put them together. So, when I am putting together, most difficult thing I will be facing is that when I am using different database and adjacent database, I will be having a problem of edges. So, along the edges there will be a variation with respect to the objects which are present. So, which we call it as the edge matching technique. We use the edge matching technique and then put them together, the neighboring map sheets into a single unit. So, this is what is the application you will have to bear in mind. So, any GIS software which has got these capabilities will be of effective use, and it will be useful to our for any kind of application. Next, coming to you, accessing the external database. So, please bear in mind, this is what I told you. Most of the time people find it difficult to use that, and most of the people nowadays, of course previously it was not that very difficult, easy. Now it has become much easier in the sense that data which is available in soft copy format in any form for your information can be directly accessed and brought into GIS environment. You can see here access to data, like say it could be vector data, or it could be grid data, it could be raster data, or it could be any other tabular data. As I was just telling you, tabular data is nothing but your tables, different tables. Then use the various formats, the tab format, the WMF format, BMP or diff format. You can see here there is band interleaved by line, that is your satellite data, and all this data, it could be also shapefile, anything can be brought. You should be having an access to all this data, bring that into a GIS environment. And the most important thing is that, as I was telling you, the DBMS data, and then use the DBMS data to bring our data from Oracle 9.1 Spatial. We have application specific to GIS, or Oracle 12c where it will be just database, MapInfo software where we have the MapInfo Spatialware, IBM Informex, that is another facility which you can bring. Then IBM DB2, where DB2 for your Linux, Unix and Windows and any other application you can bring it here. Sybase, the mobile applications you can bring the data into this. Ingress, which is again open source SQL RDBMS data or SQL data. You can see that these are the advantages in GIS. All this data which is, if it is available in that form, can be brought. Of course, bear in mind, this data cannot be brought directly into your GIS system. You have to have what is called as your connectivity. So, we have the open database connectivity, or ODBC we call it as. This is a simple programming language which will help you to connect the data from one environment to another environment. Here in our context it is GIS to from external database to your GIS database. So, we can use this ODBC connectivity, or your, even in the case of you are going to use anything like Oracle database, you can use also OCI, Oracle Call Interface. So, these are the facilities which, if available in a GIS software, will be of immense use. As I was just telling you, it may not be possible for all the software to have all kinds of facilities, because it depends on the cost part of it. So, the costlier the software, the better will be the number of facilities. So, if a facility is there, if you have the database, you can effectively bring them into a GIS environment. Let us next about the data modeling. How do you model the data? How to get the data into, once it is brought into GIS environment, what are we going to do? So, you have in general data modeling, you say that a topographic map, I was just telling you about the topographic map. The topographic map is brought into GIS, a database where in which I have n number of layers. Again you have here line, polygon and the point data. So, the 3 data is there here, and then what is that I am going to do? Ultimate aim in GIS is that obtaining the data, putting the data in GIS alone is not important, or that does not end there. When I am able to understand the data, that is one part. How am I going to use the data? How am I going to utilize the data effectively? So, in this context, we will be working with in GIS. Once the data is available for you, in which was in different form, you have brought it into a specific format of your choice. Now, I am going to use the data by querying the data. So, the simplest of analysis, as I just told you initially, of the 4 input modules in GIS, namely the input module, the storage module, the analysis module. Let us see in detail about the analysis module now. The simplest of all analysis is that I analyze the data with respect to, say, its position, or giving the data, looking at the data in a different form. For example, spatial analysis, analyzing the data with respect to space, or database querying, querying the data from the database. So, these are 2 simple methods. Let us see what is that. Query the data. When I say simple analysis, querying the data forms the basic. Select the features by their attributes. That is, for example, let me say find all districts where the literacy rates is greater than or less than 60%. So, naturally what I am trying to do here is that I am not going to use the spatial, I am going to use the attribute information. That is, the non-spatial data is going to be used now. I am going to identify those districts where the percentage of literacy is greater or lesser depending upon our choice, and then identify. So, by using non-spatial data, I am trying to identify the spatial data. Naturally, depending upon the database, depending upon the input what you make, you will be in a position to identify the data. For example, when I say literacy rate, it may select 8, 10, 15, 20 out of the total number of districts. So, it all depends on that. Now, this is what is important here. So, what is that you should remember is that by giving a database, by a simple querying, you can give a specific location, get the detail, or you can give the detail, get the location. So, in this context, we are going to use the giving the detail and obtaining the, say, spatial location. Or similarly, find all family planning clinics within the district. All this is simple examples to make you understand easily. So, then you can also put them together. For not that it's not that you have to do only a simple query, you can also go for a relational query. Try to use more than one table at a time. Find out those villages which has got an area of 5 square kilometers and or which has got a literacy rate of 50% and more. So, something like that. Try to relate the database. So, then it becomes relational query, and then you will be getting a simple output for that. So, similarly like this, you say villages within 10 kilometers of a health facility that have high child mortality rate. So, something like that. So, any kind of application. So, it is not a simple query, it is a relational query also can be with using more than one table we can try to analyze and then get the information. Now, coming back to the very important application is that a spatial query. What kind of a spatial query one can make? With the question arises, where am I, what is around me, that is search for points of interest, who is around me, search for people, how do I get there, that is to reach a specific location or destination rather. You give an input and then you ask the system to locate, then once you know where you are, you can ask the system to reach a specific destination. So, the point of origin, point of location, if given, you can reach the point. This is what an application we will see at later stage. Then also very importantly, I can also let others know where I am, that is share the location information. In fact, the present day, because whatever I told now were all huge applications previously, but of late with the advent of improvements in communication technology, it has become much easier. For example, when I talk about where am I, so I can always locate myself using a simple GPS. That GPS could be fitted in a GPS equipment, or it could be in a simple smartphone, or it could be a simple phone rather. So, when I am trying to locate myself, I say where am I. When I ask the system where am I, the system will tell you where you are. X and Y is not only the thing which I get, I also will be in a position to locate myself in the map. When I ask the system to locate myself on the map, it will show you on the map. Well, from point of as a stranger to a specific town or city, I want to move from one place to another place, we use the point of origin, point of destination course. All of you know that very well. All smartphones have got that facility. You give the point of origin where you are and you ask the system to show you the route to your destination, automatically the system will give you. So, all these things are done only using GIS. So, this is what is the role GIS plays in your present day technology of using your smartphones in an effective way to locate yourself, to move from one place to another place. This is what is a good application you have. Please, coming back to the next one, namely the analysis part of it. So, when I was telling you about the analysis, a simple query, then finding out where am I, we talk about the analysis in the form of buffering, point in polygon operation, polygon overlay, geocoding and address matching, network operations. The simplest of all is buffering technology, buffering technique rather. So, we find a specific application, any kind of application for that matter. We want to know, for example, find all settlements that are more than 10 kilometers from a health clinic. So, this sort of an application is not only for this one, buffering is such an important one in studies like say health, or even in the case of in fact some of the applications what we have done is that finding out a specific location where voting can be take place, or a polling booth rather. I want to go to my polling booth, where am I and how far is it from that. So, this context, if I know the polling booth, the polling officials can identify or put a buffer for that particular point and try to get the actual coverage of that particular polling booth. So, this is what is the good application. In fact, this is very useful in the case of your inaccessible areas. Not only that, we talk about buffering for various applications, namely for example, your wild habitat. If you want to close or you want to have restrict somebody movement of human being for a specific application, you can say 1 kilometer from this particular garden or park, you should not have any kind of movement of human being, something similar to that. So, any kind of thing wherein we just try to spread, or when we want to have a buffer around an object, this buffer techniques plays an important role. In fact, I will show you a very good example later, you will get a better idea what exactly I am trying to say now. Now, coming back to the next one, point in polygon operations, wherein which we say that identify all the villages into which this particular vegetation they fall. Of course, this is a very crude example. For example, I just want to find out villages which are very much abundant with say paddy cultivation, villages which are deprived of paddy cultivation, or water supply, villages which are given proper water supply, which are not given proper water supply, or towns which are affected by any kind of a specific pest or anything kind of a dengue or any kind of vector borne diseases. So, in that context we can use this effectively. So, point and polygon. So, you can just try to find out, identify that, and it will be you will be in a position to understand what exactly we are working with. Then next important thing is your polygon overlay, the one of the most powerful tool in GIS, combining the various administrative records with the health district data. Polygon overlay. In fact, as I told you, one of the most powerful tools in GIS is your polygon overlay. Point over polygon shell, it is not that very straight. Similarly, your buffer also is one important application, whereas polygon over polygon, all these things makes an important study. Almost all kinds of resources study, all kinds of applications, we use this particular context and application. So, that is your polygon overlay. Coming to the geocoding or address matching, very important thing. In fact, geocoding or address matching, please do not confuse with georeferencing. Georeferencing is a process wherein which we try to make the system to understand a north coordinate system, earth coordinate system into earth coordinate system, but geocoding is not like that. For example, geocoding is done or address matching is done in places where postal department comes into play. A simple example I can give you. When I have the street data, I also have, I do not have the parcel data, I just have the street data. Normally what we tend to do is that we try to use the geocoding technique by which we will be able to locate ourselves approximately, not at the exact location, approximately in any given road using the address. So, normally addresses in of course various parts is given in different methods. In India, we have address in such a way, on one side we have the address, the numbers will be odd numbers, other side will be even numbers, 1, 3, 5, 7 on one side address, and the same door numbers will be 2, 4, 6, 8 on the other side. If this data is available indicating this particular street has got 40 houses, 20 on one side and 20 on other side, it is not a compulsion, it could be 20 to 18 also, and they are numbered properly. So, if the numbers are there and if the address is present, we can identify ourselves using this address match technique, a very simple and unique technique. Of course, I will not be in a position to know exact location of that particular house, at least close to that area. So, this is address matching technique is a very important application in GIS. Next, we have a very important application, namely the network operations or find the shortest route from village to hospital. This is an excellent application. I was just telling you about the line data and polygon data. When somebody is interested in using road for developmental purposes, we use road as a polygon data. When somebody is interested in using road as a source of flow of material or flow of resources, we use road as a line data. So, see the major difference. When I am using line data or road as a line data, we will be having huge influence on various applications. We say the network analysis and our connectivity. So, we try to connect ourselves from one position to another position. So, we say that once there is a connectivity between one object to another object, then it is very convenient for us to understand how the resources are flowing. Simple example, flow of your bus from one point to another point when the bus is moving. In fact, when we are talking about the point of origin, point of destination locate, this network analysis being used. We can also have alternate routes. So, a given route or a described route can be present. You can also have a alternate route for a given route, because it is not that always you will be in a position to move in a specified route, isn't it, because you will have various issues. So, similarly, when there is a movement of VIPs, VVIPs, they use alternate routes or routes which are specific to them. So, network analysis plays an important role in resources flow. Probably we will see the details at a later stage. Let us see how GIS can be effectively used in various applications, especially probably important to architecture planning. Let us see how buffering can be used effectively. As I was telling you in the last class, how buffer can be created. What a buffer is? Buffer is nothing but creation of area of interest around a point of importance or origin. Now, when I am creating a buffer, I tell the system, or I just create a area which will be constricted or restricted. This could be half a kilometer, 1 kilometer, 2 kilometers, depending upon your requirement or application. Let me see that how modeling can also be useful. Now, when we are talking about modeling part of it, so initially we just saw the analysis part. Let me talk about the modeling part of it. Identify or predict a process that has created or will create a certain spatial pattern. For example, diffusion. When I am trying to model the data, I want to know how far epidemic spreading is taken place in the area. I was talking about the vector-borne diseases like dengue, malaria and other things. A very, very important thing, isn't it, for especially in people who lives in the lower ranks of their life or society rather. They find it difficult to even have good health, especially in small slums, where in which they get affected very fast. In the case of people who are affected health, most important thing is your malaria and dengue are the two important things. I want to model such a thing, I want to study, I want to find out what could be the possible reason for the spread of the vector-borne disease. So, in such a case, I can use buffering technology, I can use a point over polygon or polygon over polygon. So, this is a diffusion of a specific epidemic in and around an area. Then there is another interesting thing when you are talking about human settlements. Where do people migrate to? From which place to which place? Why is it so? So, what is that? What is going to happen? Why people are trying to move from one place to another place? A simple analysis or study. As a modeling expert, you should be knowing migration due to various reasons that we are not going to discuss now. We will be knowing if a set of people, a group of people are going to migrate from one place to another place, what is going to be the impact, the environmental impact in that new area from one point to another point. Well, similarly, what is going to happen if I am going to construct a dam? Construction of a dam, you know that hand in glove is your reservoir. For a reservoir, you need large areas, dispelling the existing population there. So, in such a case, if I were to construct a dam and reservoir, what will happen, or to what extent I am going to acquire the land, what is going to happen to the people, where am I going to place them elsewhere. So, this is the kind of study you can do. So, modeling techniques are huge in nature, only small very little things we are discussing here. Once we come to that level, we will be discussing in detail various applications. Simple, I was telling you about the spatial analysis. A simple application. What are the things are what people will be interested in knowing? We would like to know how many homes have got a telephone, which are the homes which contains the dog license, how many shops are there in a specific location, who are all the or where are the specific cable TV customers, is there a specific pattern with respect to the car ownership, or we have any constraint or restraint for planning in the area, because probably this might be a direct application to you, planning in a given area. So, restraints or constraints in that area, or you want to know what is the change of a change in the population, pattern of population over a period of time, 10 years, 20 years, etc. So, this sort of an analysis GIS comes into play. So, let us see spatial query and a spatial query. I was just telling you about that, spatial query and a spatial query. Spatial query is nothing but, as you see on the left side of the map slide, you have the map part of it. So, querying from the spatial map, this is a replication, just indicating this is the replication of this, and this is the detail about this particular object. It need not necessarily be the same here. A spatial query and spatial query. A simple query indicates or you find out identifying an object and its attributes or details by location or attribute query. We say you give a location, ask for the detail, or give a location or ask for the detail, or give a detail, ask for the location. So, that is I think you understand that. You can give any kind of a detail. I just want to find out Where is a specific cinema hall in a specific area? You get the detail. That's you give a detail as per the location. Or in your location, you want to know or find out if you have any kind of shopping mall, it will be in a position to give you. So, this sort of details will be possible from GIS. Similarly, manipulation, we talk about data manipulation. What happens? You say what if situation. What happens if a chemical is leaked into a river? What should happen? Naturally, you should understand, if a chemical is leaked into a river, what will happen? You should be in a position to analyze that. If a green belt is existing in that relating to the city or not, yes or no, you can do it. Or you want to find out if the population has changed over last 10 years, yes or no. Or you have any spatial relationship with respect to the car ownership in an area. Of course, in countries like India, it may not be there. In foreign countries, this sort of an application is a very unique one, especially the car ownership details. Well, coming to that, what are the tools which will help us in identifying and working with in GIS rather? So, we have tools such as within a given radius, if you want to find out, use that tool, pull that and get the radius, define the radius of 1 kilometer, 2 kilometers, we can get the data. Or within a rectangle area, you can get what are the details. Or within a polygon, need not necessarily be a regular object, polygons are not supposed to be non-regular nature. Once I make a selection, I may also have to do an invert of that. So, invert selection. For example, out of 100 I make a selection of 30, I want to invert it, I can use the invert selection facility and then do that. Well, next important thing is your hot link. Hot link or HTML image maps, how do you use that? Thank you.